Hey, how's it going? Today I wanted to talk to you about one of the techniques I use in order to parallelize my workflows and increase my productivity and efficiency when trying to run some sort of analysis, whether that be running predictions with some sort of machine learning model or computing some type of statistics or metrics on a bunch of input data. One of the things you'll find is that the more projects you work on, the bigger projects you work on, you kind of need to move beyond just running through things sequentially, and you need to move into the more parallelized realm so that you're able to utilize the resources that you have available to you to the maximum, and you're able to accomplish work in a much more efficient and timely manner. So the library that I want to start with is the built-in multiprocessing library that comes already installed with Python. And I'm going to walk you through a couple examples of how I use its functionality in order to increase the efficiency of my workflows. So before we get into actually coding things up in Python, I wanted to walk through just a simple diagram I drew up to kind of explain exactly what the aim is and what's going to be going on and what kind of function we're going to be trying to write. So basically what you have here on the top is you have a list of inputs. So they're going to be a list of different values that you want to be passed to a function, which will run some type of analysis. And you want that analysis to be distributed across your cores or across your machine and into parallel processes. That way you can get outputs from multiple different workers at the same time or in parallel, instead of having to iterate through each particular input one step at a time. So basically how this works in the multiprocessing library of Python is you create a pool of workers and they're actually worker processes. So usually what you're going to want to do is you're going to want to make one worker process for each compute core on your machine, so for each CPU. And then, like I already explained, is each process will be able to take an input from the list of inputs and compute the analysis or run some sort of function on it, and then generate the output. And then that core will be constantly pulling from the list of inputs and along with the other cores. So each one is going to be able to be doing multiple different processes. Each core is running in sequence, but since they are all running at the same time, then you're able to process the amount of workers in parallel. And that is kind of just the basic rundown of how that's going to be working. All right, so now let's get to actually programming this up in Python. So first what we're going to do is we're going to import the libraries that we're going to be using today. Okay, so as we get to these different libraries and the function we'll be writing, I'll kind of explain what they're doing and why we're using them. But for now, the main focus of this is going to be the multiprocessing library, which we imported at the bottom there. So like I'd showed you, we want to create some kind of function that creates, a pool of processes and a pool of workers that takes as input some sort of function and then also a list of input values that we want to pass through our function. So we're going to go ahead and define a function here. So one of the parameters that we pass is function, and then values, and then I'm going to put description equals none. So I'll explain exactly what that means once we get to it. So now that we kind of have that kind of laid out, now we kind of want to walk through how do we actually utilize the multiprocessing library. So we're going to go ahead and create a list for our outputs so that our pool of workers have a place to store the outputs after they've been passed through the function. One of the things I like to do is use progress bars, which is why we imported the tqdm function from the tqdm library. So what you're going to do here is you're going to say the total length of progress is however many values we get as input. We want the progress bar to be read out to our standard out file. And then for a description, we're going to pass whatever we give to the overall function, so that will pop up next to our progress bar and give us a little description of what type of analysis we're doing. Okay, so now it comes to the actual multiprocessing functionality that we're going to be using. So I'm going to write out a little bit of code and then I'll explain. Okay, so basically what I wrote here is that with multiprocessing pool, with the amount of workers being equal to the amount of CPUs we have on our machine, I want to run the function IMAP unordered on the function that I passed and then also the input values. So for each result that comes from that pool, I want to append that result to the output list and then also update my progress bar. So built in with the multiprocessing library are a bunch of different built-in functionalities, and one of them is the IMAP unordered, and I will leave a link down below in the description to where you can look through and read the docs on the different functionalities, the other different functionalities that are built in, and what kind of makes the difference between them. All right, now just to kind of show you how this works and what it might look like, I'm just going to write some kind of arbitrary function, and then we're going to run it in our console so you can actually have some experience with it. Okay, so what this function does is basically takes in a value, and then it'll write value I, and then it'll create a data frame, and then it'll write it out to a CSV. So this is an extremely simple function. This can actually be used with a lot more complex functions, and it's versatile, so it can be used with different types of all kinds of different functions. But this is just kind of a good practice use case just to explain and demonstrate how it might go together. So here we go. We're going to go ahead and open up our console, and we're going to go and cd to our current working directory. So if you take a look, this is where my script is. So what I am going to do is I am then going to actually first I need to actually give it some command. So if we run the script, it actually does something. Okay, so here I created a list of indices. So it's going to be arranged 30, so from 0 to 30. And then I'm going to pass that to my pool function. And I'm also going to pass my CSV, write CSV function. So what it should do is from 0 to 30 should write out 30 different CSVs to my current working directory. So we're going to go ahead and open up our console, go Python, run our script. And here we have the progress bar that opens up. And if it's, there we go. So kicked them all off in parallel, and here we see all of them populate into our directory. All right, so at the beginning of the video, I also had talked about how this particular function doesn't necessarily take multiple arguments, but there is a way around that in order to be able to map multiple arguments to a function and run it in parallel. So I'm going to walk you through how to do that now. So I'm going to write out a similar function, but we are going to name it slightly different. So okay, so we can see here that this write CSV multi actually takes multiple arguments, not just one. So how exactly do we go about passing that extra argument? So I will show you here. So that's why we actually imported partial from functools. So we wrap our function in the partial command, and then we set the arguments that aren't the indexes being sent to the pool. We set those arguments. It could be more than just one. It could be multiple more. We set those. And then we map the indexes to what's now this partial function, right? So pool is now being passed write CSV that's wrapped inside partial, and then we've set these, we've essentially hard-coded these different arguments. So go ahead and run that. Oh, so I got an error. So it actually should be write CSV multi. And I'm actually going to delete all of these. So that we can see if this works or not. And there we go. That worked now with multiple arguments. All right, so now I've covered basically the most generic form of this pool function, and then how to pass functions with single arguments or multiple arguments to it. So as we can see, these are all functions, and they're all global functions. So they're defined within the scope of the entire program and have access to the main module. So where you might find yourself in a situation that I found myself in, where recently I wanted to run this type of operation with inside of a Python class. I started to have issues with that though, because what actually happens under the hood is when this pool of processes is being instantiated, it's actually pickling the objects inside, and then it's able to transfer them amongst the cores and is able to run them as individual Python processes. So when you try to do that inside of a class, you don't have access to this main module and the global scope, and you tend to have some issues. So I actually recently came up with, or I guess was able to come across some different types of instruction and different types of material that help me kind of figure out a way around that particular problem and help me figure out a way to use this functionality within my Python classes. So I'm going to walk you through that now. So first we're going to define what's called the parallel class. It's what I call it, where we're going to create the same pool map function, but it's going to with just slight differences. So we're going to go ahead and just copy paste. And then the big difference here is that instead of just passing the values to it, what we're going to do is zip self along with it. Also, we need to define self within the function. So now when the function receives the values, it doesn't just receive the values, it also receives the mapping to this particular self, so this instance of this class, right? So then it's able to run the actual function. You won't have any issues. So now if I would like to work this into some other class, I want to inherit this functionality into some other working class, you'll just do the following. So here's my new class, and I want to inherit the functions from parallel. So I pass parallel as a parameter here. The parameters that need to be passed to initialize an instance of this class is an output directory. And then since we inherited from parallel, it already has this pool functionality built in. So I'm going to define another functions, and they're relatively simple. These same types of concepts can be applied to any type of function that you would like to use. Okay, so here we are passing the function, which I haven't written yet, unwrap file, and then we're going to pass it a list of file names if they end in CSV, and then our description for this is parsing directory. All right, so that will give us a list of outputs. So what we're going to do is we're going to turn that list of outputs into a data frame. Okay, and then we're going to define one more function here, and then I will kind of, or two more functions, and I'll kind of explain how these all go together. Okay, so there's quite a few things going on here. So let me kind of try to break it down and explain. So what's going to happen here is we're going to send for our function to our pool of processes. We're going to send unwrap file. What unwrap file does is it actually grabs an instance of new class, and it grabs that particular function, which is getMean, and it returns that with any args or kwargs that were arguments or keyword arguments that were sent to that function, and it returns whatever that output would be. So if you come into getMean, then it also will then read the file and then return the mean of the value column. So when you're trying to run this type of pool processing within a class, one of the things you need to make sure you know is that the sub function can still be an instance function, but any functions that feed into this sub function, which is getMean, which is unwrapped with the unwrap file function, any functions that are sub functions of that must be global, have global scope. They either have to have global scope and should be defined outside of the class, or if you're going to define them within the class, they must be what we call static methods. This allows this function to be tied to the class, but not actually interact with the object of it. So, interact with the class object. So, as you can see, I don't actually have to pass self here. It's basically like a global function, but the reason why if I might want to have a couple different classes, right? All of which need to have this global read file, but they need to do different things. Well, then I want to make sure I tie this one specifically to this class, so I'll make it a static method. And then once that becomes a static method, then you just have to change this here to new class. All right, so now that we have this coded up, let's go ahead and see if it works. So as we can see, what I want to do basically is just parse this input directory and read all the CSV files, and then get the mean for each CSV file, and then output it to this list of outputs, and then create an output or create a data frame of basically the list of the means in this directory. So let's go ahead and come down here. First, we need to create our process. So we need to create an instance of the new class, and then we need to pass the output directory. So we're going to go ahead and do our current working directory. Now that we have an instance of that class, we can now run the functionality of read directory, And then this also takes input as which directory do we want to parse. So we're going to go ahead and call our current working directory again. And then at the end, I want to print out the mean of means. So this data frame is going to be a list of the means, so I want a mean of that. So go ahead. Go ahead and do that. All right, so what we're going to do. Also, before we can run this, or no, never mind. Yes, we should be able to run this with the same environment, so go ahead and run it. Here we can see it's parsing the directory. Oh, so I had an error here, so I must have misspelled data frame at some spot. Here we go. Let's go ahead and try that again. Seems like I have another error. Give me a second here to kind of figure this one out. So if we actually take a look at our read directory function, I forgot to return the data frame. And if you see down here, I actually set it as it was returning it. So we'll go ahead and make that change, and then we'll try to run it again. And there we go. Now you have the mean of means coming out of there. So everything seems to be working properly, even though we're calling that multiprocessing pool function from within a Python class. And there you go. Today we were able to cover one of the techniques I use for scaling up and parallelizing some of my workflows, and a few different ways on how to implement that particular functionality. I hope you were able to get something meaningful out of it. In the next coming video, I'm going to cover a different type of scaling that I use, where I use a different Python library, and it has a different kind of feel and different workflow, and is used for different particular problems where this approach doesn't necessarily work, and is able to solve the same type of problem, but just in a slightly different way. So hope you're able to get something meaningful out of it today, and I hope you enjoyed, and we'll see you next time. Thanks.